So I'm going to determine the roots here of x to the power of 4 plus 3x squared minus 108. And to do that, to start, I'm going to have to think about my x to the power of 4 and my x squared as x squared and x. So again, we're going to think about x to the power of 4. We're going to think about that as x squared and x squared as x. And so to start, just like we would if it was a normal quadratic, I'd find factors of 100 and negative 108 that add up to 3. And conveniently, I know that those factors are going to be 9 and 12. So they're going to be 9 and 12. I know my 9's going to have to be negative because negative 9 plus 12 would give me 3. And so now we're going to come back to using this x squared and x. So normally we'd put x plus 9 or x minus 9 and x plus 12. But since we thought about it as a double degree here, this is now going to be x squared and x squared. So if we wanted to go back and check, we would still get x to the power 4 plus 3x squared minus 108. We just doubled everything and cut it in half to help us think like that. So now that I have these two factors, I can go ahead and factor one of these further, being the x squared minus 9, because that's a difference of squares, to be x plus 3, x minus 3, and those two x's would be x equals negative 3 and x equals 3. So that's great, but now we have x squared plus 12, and we cannot really factor that one further. So we have options here. Either we're completing the square, quadratic formula, or using just solving this algebraically. The best case in this one for us to use would be to solve this one algebraically because we don't have a middle x. We just have one x squared. So by doing that, we'll have x squared minus 12 or plus 12 is equal to 0 because we set it equal to 0. I subtract my 12 from both sides and I'll get x squared is equal to negative 12. Then I take the square root of both sides and I get x is equal to, now the square root of negative 12 would give us an imaginary number. So that would be something I, and I have to factor my 12. So my factors of 12 are 2 times 2 times 3. So I take out my pair of 2's and leave my 3. So it's going to be equal to 2 root 3. And we have to remember here, because we took the square root and we have an imaginary, it's going to come as a conjugate pair. So it's going to be plus or minus 2i root 3. So therefore, my final answer for all of my roots would be x equals negative 3, positive 3, and then plus or minus 2i root 3. And that would make sense because due to the fundamental theorem of algebra, our degree here is 4. And we got 4 roots, 1, 2, and then the plus or minus, that would be 2 as well.